All right. The thing is live. It says we're back. Yes, I know. I was slacking. I may or may not have gotten dragged out on a Saturday evening for a whole bunch of fun in downtown Boston. These things happen. Yeah, when you're not 20 years old anymore, it takes a little bit more recovery time. So we're doing a quick pre-lunch session. We're gonna wrap up most of this stuff and things here. So let's just bring up our notebooks real quick here. Okay, got that guy. Let's grab our SI diagram because we have another notebook. I apologize. I'll share my screen in just one moment here. All right, here we go. All right, let's do the dangerous thing. What's going on, everybody? Memes here. We're just trying to play catch up while I'm being an old man catching up from playing hooky on a Sunday. It's all right. We're recharged right now, loaded up. All right, entire screen share. Boom. Here we go. Let's delve into it. All right, so number one, let's see if we can't use our notebook assistant. Hold on. Uh, Wolfram, account, blah, blah, blah. Oh no, it's information. All right, here we go. Could probably just do the normal Mathematica thingy to bring it up. Let me go back. I'm just going to create a chat notebook and we'll see if we can't construct an SI-based diagram. Let's let's see just how advanced this Wolfram technology is. I got a Mathematica, a new chat notebook. All right. Let's take our SI base diagram. Huh? Copy image. Oh, can I input an im? Oh, it let me put it in. Well, let's see what happens. All right. Please analyze this picture of SI relationships and their SI base units and their relationships. Please help me design an image. Uh, Please help me write some code to help illustrate these relationships, preferably in a circular layout with the base units being on the periphery of the circle. Okay, I have no idea if this is going to do anything useful. I should probably just list all the units and everything out. I'm not sure of its full ability to scan. Oh, I should probably submit it. There we go. All right. Let's see if it comes up with anything. I just asked it to do a lot. Like I had ChatGPT last week try to start doing something. Oh, it's thinking. I think it's thinking. Probably should have had this image separate. Okay, let's just go back to our other thingy here. All right. So yeah, we're gonna need some more base measures. All right, let's go back to Nest over there. Okay. I'm just gonna let that think for a while. All right. ST redefinition. Let's go through here. Go back to the meter. All right. Let's see. Interminable distance. In interminable distance to grandma's house will stand a clock. What is interminable? Endless. Off to grandma's house we go. Okay, the meter. Um, Right at our fingertips. Yeah, we used the cubit. Ancient Mesopotamia was the cubit. Okay. Later measurements used by Romans. Okay, so let's add this over here to our sources, cubit, stands, meters. And pass them to Europe, length of human foot, multiple, blah, blah, blah. Human units, uh, standardized make measurements largely based on variable things. All right. India and China standardized units before Europe, who still lacked standardization until the 1800s. All right, you late. There's land a rod, like 16 randomly selected men's feet, and multiples. Oh God, is that how we got the acre? I.e. Uh, on such unit was the rod, which was a randomized collection of 16 different men's feet. That retrospect is the modern idiot. Okay. A man could plow in a day. This measures further dependent upon the crop being grown. Wheat, different sizes of an acre of barley. This was fine so long as accuracy and precision were not an issue. Okay. Yeah. Okay. If just for small scale, such as an individual's farm, usually wasn't much of a problem. Uh, for large scale problems or those involving precision, such as commerce, uh, of course, uh, issues would arise. It's kind of like, what is it? Oh, pi? First level pi? Yeah, three. That's kind of good enough. If you just make it a rough circle to, I don't know, do a little dance or something in, maybe that's not so bad if you're trying to have high precision things where, I don't know, you want five significant digits to a circle. I'll probably cover you for most general things in human scope. Yeah, you want that extra precision. Otherwise, you're gonna run into issues. Okay, so let's go back over here. Okay, file, again, save often. All right, so this is 30. Oh, we skipped ahead. All right, 6. Save there. Save to cloud. See what else we got for the meter. 18th century, of course, the French Revolution. Yes, as a result, like that to establish just a universal system of measurement, one that was based on wasn't based on bodily dimensions that varied from person to person, place to another. The French sought to create a system that would endure for all time, for all people. To this stage, French Academy of Sciences established a council of preeminent scientists and mathematicians. Da, da, da. A year later, it was emerged a set of recommendations would be a decimal system plus some powers of 10. The measure of the distance, the meter, metron. We 1/10 millionth of the distance between the North Pole and the equator, with that line passing through Paris, of course. The measure of volume liter will be the cube of a distilled water whose dimensions were 1/1000th of a cubic meter is a unit of mass, where a kilogram would be the weight of a liter of distilled water. Oh, volume. Okay. Oh, done. What's going on, bro? Oh, check, check. All right, now okay. Maybe it wasn't even going through before. I apologize. Wow, I've been rambling on about nothing. Hold on, let me check my in. There we go. All right, hold on. Make sure this is right. Okay, let's check again. Actually, that's probably a good thing. I probably wasn't even broadcasting at all. All right, there we go. We've adjusted it. Cool. All right, let's get. Let's see if we. Okay, that did nothing. Okay, hold on. Let's quit the kernel. Where is this? Edit, format, evaluation. Let's quit the kernel. All right. Okay, so let's do this. Let's separate this into two things. Okay, let's just go back. All right. Yes, yes, yes. Okay, now it's broadcasting. Hey, Keishal. Thank you for joining. Yeah, we're just catching up and finishing off our little thingy of units. I was definitely slacked yesterday on a Sunday. Let's get it back up and finish this stuff before lunch. And by lunch, I mean it's lunch now, so, but I got like 40 minutes. Okay, alright, so, light. Hold on, should be up here. Alright, so that's back for the history. Alright, file, save. Of course, the measure of volume. Alright. Oh, and then they divide the kilogram off that. Cool. Alright. God, how coincidental. Okay, so we had the meter, which was... by million. Alright, so... volume was defined as 1/1000th of a cubic meter of water, of distilled water. Okay. Okay. Okay, so we're getting. Okay. Unit of mass, more practically weight kilogram, weight of a liter of distilled water. In a vacuum, completely empty space. All right. Okay, and 1792. Sent out to measure the meter versus surveying for Barcelona, Spain. After 7 years, they arrived at their final measurement. Okay, it was latest made errors in the calculation of the curvature. For his low prototype meter was 0.2 millimeters shorter than the equator. All right. Let's see. Early calculations of the Earth's curvature based on these definitions. On this definition was off by approximately 0.2 millimeters. Led to a discrepancy of 0.2 millimeters per meter. Okay. It's kind of thing that keeps measurement science. Stuff at 9 that are listed the submarine as realized in the platinum bar, blah, blah. As time passed, more and more countries adopted the French meter as their line standard. However, while these copies of the meter bar were meant to be exact, there's no ways to verify this. Okay. They continued. People signed on. Alright, it's 1875. Alright, the conference to measurement. We went over that before. Now, bureaus of weights and measures also established a type located outside Paris, France. Bippen served as a focal point which members act on matters of meteorological significance. It is the ultimate arbiter of the international science units. Repository of the physical measurement standard kilogram was the last of the artifact-based measurements. It was officially replaced. Okay. The bar won't be flat, but have an X shape to better resist distortions. Okay, if you're gonna have a bar, something like that. Copy image. Let's just do input. Let's see, where are we going? Oh, wow. Okay, how about this? I'm gonna do something very naive here. I'm just gonna put a plain text thing in there. Okay, I'll copy it from here. Copy image. Hold on, let's delete this. Let's close out of that. Let's go to a new notebook. Okay. Da, da, da. All right. Help me code base units of SI and create a chart showing relationships to derived units. Okay. Oh, it's doing something. All right, let's see. It's thinking. It's thinking. I want to scratch some screenshots, so. Oh, wow, it's thinking a lot. Is it even moving? Did I lag out the kernel? Oh, we'll let it do its thing. Oh, I saw it move. Oh, it's moving. It's moving. Is it gonna do something cool? Let's see. Cool stuff, no whammies. Cool stuff, no whammies. Come on. Almost. It's making me want to jump to another screen. I want to jump to another screen, but I don't want to miss it. I'm gonna miss it, aren't I? Okay, I can accept missing it. Alright. Welcome back, Dan! Yes, no, we're catching up. Did it finish? No, it didn't finish. Okay, we're just gonna continue with this. Alright, so this was, oh, that's some cool pictures. Alright. Alright. Image of course, we're doing platinum, iridium, everything. Iridium of the platinum iridium bars used up until 1960 for the unit meter. Okay. I'll save. Alright, to create a chart showing the relationship between SI base units, we can start by defining base units and the derived units. Okay, here you can choose using the Wolfram language. Okay, blah blah blah, luminous intensity. Oh, okay. So, let's insert and evaluate. Okay, now is it... Oh god, that was a lot of stuff. It did a lot of thinking. Wow. Okay. So let's do that. Hold on. Let's do it below. I feel like this would be more useful. Okay. Let's embiggen this because they wanted us to keep track. Okay. So let's first copy this. All right, let's grab our code. Let's throw it down here. Yep. I'm gonna paste the cells. Okay. Let's evaluate. See what we get. Should be thinking. Or maybe, oh, we're just literally setting units. Okay. So, all right. Well, that's trivial then. Okay, so we got coding units, base units. Now let's visualize these relationships using graph. For simplicity, we'll use the arrows. Okay. Alright, let's copy this. Huh? Okay. And now below that, let's put this code in here. Alright, let's evaluate and see what happens. Alright, so we got some issues. Alright, let's see. Did I just need to put this in a cell immediately below this? Let's try this. Let's put that there. Let's evaluate. Hold on. Alright, let's try this. Okay, so we're getting some errors. Alright, so let's do another chat cell. I got a bunch of errors. Please help. Channeling my inner Professor Wolfram. Because here's the thing, a lot of times you'll see him, he'll be going out and he'll be talking very eloquently. The amount of hours he has spent grinding away, where things can be very painful. He's like, guys, we're going to get this, we're going to do this. And so often I'll just hear him say, like, no, help. It's literally on the Discord at one point. All right. So, all right. It's thinking. Let's see what we got. All right. Come on. Give me something good. Okay. So we got a bunch of stuff there. What's it say? Is it protected? Does not have appropriate bounds. Does not have appropriate bounds. Oh, God. No. That's not a good sign. Let's see. Let's quit. I'll give that another few seconds. All right, yes. Sipping on it with lemon juice is probably the best. Yeah, yeah, that one crapped out. All right, so let's reload. Let's just go to our random notebook here. Okay. It's thinking, it's reloading. All right, let's go back over here. Let's not waste our time. 19 precision measurement of the meter can make quantum leap thanks to advances made in 40-year-old technique known as interferometry. This technically wave light could be measured in such a way that could interfere. Precise measurements between the waves. All right. National Bureau of Standards advocated for the interference patterns of energized cadmium atoms to be made as a practical standard of length. Okay. It's useful because the international measurement arts such as meter bars cannot be everywhere at once. How with proper equipment, scientists anywhere. Oh, why? Thank you for trying to update those things. Okay. So I did a bunch of things. Okay. So it actually outputted. The errors you encounter is due to incorrect syntax in the table, specifically issues you arise for how you're trying to iterate over the relation. Let's fix the codes by setting up the ratios correctly and plotting them using flattened. Ensure the edges are constructed properly for the graph. There's the corrected version of the code. All right. So let's copy. Let's put our code in here. Let's evaluate our code. Oh God, it broke even more things. Okay. That seems to produce more errors. Please help. Okay. All right. Let's see. Is it gonna think? All right. Well, that's thinking. We're gonna go back here. All right. The interference of energized cadmium, to use the practical standards, is useful. Anywhere can measure in a meter with cadmium. Their copies, exquisite might be, are not as accurate as the real thing. Neither an artifact nor a card is suited for every measurement one might want to make. To cite a real-world example, gauge blocks lengths are used for standards commonly used in machining because it's extremely fine work as a man and machinist. Their calibration must be finely crafted as well. Using cadmium and krypton wavelengths, gauge blocks can be certified to being accurate within 1 part per million. All right, so like 10 to the 6. 3 times closer than previously. 3 orders of magnitude ain't too shabby. 1940s, nuclear physicists aimed neutrons at gold to transform the atoms into mercury. Notice that railways at this form mercury, known as mercury 198, would produce green light with a well-defined wavelength. They produced a small amount, started experimenting with it. In 3 years, a precise and convenient way of defining the meter. All right. Use in all probability the line will be used the wave as the ultimate standard of length. Measured this wavelength green light. Okay, a billionth of a meter would be defined as a precise number in multiples wavelength. To induce praise, how are funding to do this? Let's see. Advocate for the interference, as this was useful because international measure. Okay. So, okay. All right. In the period from 19. Okay, go back. All right. In a period from 1927 through 1951. 1951. Who did it? Okay. NIST advocated for use of for use of the interference patterns of cadmium energized energized cadmium and later mercury. Which cadmium was that? Just cadmium. Okay, they're not listing. All right. And later mercury 198. Due to the now no. Higher precision. God, I can't spell. Perversion. I'm perverting something. Precision of interferometry. Should probably say what the heck that is, to be fair. There we go. Precision. Alright, see? We can do things. Am I brave enough to take on the Wolfram language? It's mostly because I have a chat assistant, Dan. Oh god, I mean, dude, I struggled through some of the very basic things. It's like now, okay, I can kind of see. I can at least try to ask some questions. Um, the iteration should be structured correctly to generate the edges. All right, how about this? Let's do this. Here's what I know how to do. Clear all. F. We are all functions. Okay. There we go. Alright, let's try this one more time. Let's see what we get. Alright. What will happen? Okay, so let's do this. What I learned from our little coding session is... let's highlight these cells. Let's that off over there. Let's go over here. Okay, let's highlight these last two guys. Let's highlight all these guys. Go over here. Let's highlight our code. Well, let me go down. No. Oh, there we go. All right. No. Oh, I'm so dumb. Here, we'll just do this. Shift. Come on. Wow. Why is this so hard? Okay, go down further. And if I hold shift, it should get the rest of these cells. There we go. All right, now that's our chat cell. It's gonna. There we go. All right. So let's go up to here. Highlight. Come on. Wow. All right, hold on. Okay, you can highlight all those things. I'm okay with that. All right. Let's just grab. There. Okay. I got these errors. Please help. All right. Any more? I mean, this is literally what Thad did for a while with ChatGPT. Maybe I'll just use ChatGPT if this doesn't working quite as well. I feel like, yeah. Oh well. Hey Rick, it's good to see that you are temporarily present. It's good to see people, because time is a fickle thing, some may say. All right, it's not immediately available. Blah blah. That's in hindsight, that's a terrible name for things. In the end, Mercury lost to Krypton. Why? because it prevents Superman from entering your house. From which Superman, of course, they had to make the joke. Natural Metro is widely available. Okay, this still isn't as bad as the lumen definition. In 1960, the CGPM agreed to the new definition of meters. The length equal to one 1,650,763.73 wavelengths in the vacuum of the radiation corresponding to the transition between levels 2p10 and 5d5 of the krypton 86 atom. In other words, when electrons of a common form of krypton make a specific energy jump, they release the energy in the form of reddish-orange light with a wavelength of 605.8 nanometers. Add that up to that many, and you've got a meter. Okay. Oh, this is fantastic. So when was that? All right. So in 1960. Officially, 1960. Okay, what is that? We used that before. It's the GCPM. CGPM. All right. The General Conference on Weights and Measures. During the 11th. What's the 11th, right? The 11th. General Conference on Weights and Measures. That's what it is. General Conference on Weights and Measures. General Conference on Weights and Measures. The 11th. I swear I can remember. General Conference on Weights and Measures. The formal definition became. All right. Formal definition of the meter became the length equal to, okay, of a krypton atom. Okay. So the wavelength of energy emitted by an excited krypton 86 atom multiplied by the definitionally given number of wavelengths. Oh my god, it's like we can count! Imagine my shock. Alright. Save. Again, yeah, and it's like, yeah, did another thing. Light. Alright, talking about the speed of electromagnetic radiation. Incredibly fast but finite speed can be calculated as distance is speed multiplied by time. This is a great way to measure distance to satellites and other spacecraft. Speed of light is known as the backbone of the GPS network. Alright. Knowing the speed of light. Alright. Measure the Earth's surface. Speed of light for centuries remained exclusive quantity. Close into it. Blah, blah, blah. Highly accurate. Blah, blah, blah. Boulder, Colorado, NIST. Alright. Laser light. Novel laser stabilized. Frequency of light. Blah, blah, blah. Methane gas. far reproducible than anything else, led by NSD physicists Jan Hall and Don Jennings of relative value. All right, that's pretty good. I think it's 5.8. Yeah, it's like 5.80. 100-fold improvement. That ain't too shabby. All right. New speed of light, a few months, blah, blah, blah. Modulating the 633 nanometer line of helium. User value, okay. Well, not determined with low uncertainty, claim a few months. It's consistent. Building, okay. Length, okay. This octant the speed of light. Length is no longer, okay. All right. Let's redefine the length of pasture, okay. All right. Then, okay. 1983. He was finding as a length. He nailed down the speed of light to its current, not to be confused with later current, not to be confused with current that we shall discuss later. Hey, you gotta be a little lively here. It's current value of this. Of 299,792,458 meters per second. Okay, there we go. Got that. All right. This was of 2019. Okay. Alright. Of course. It all seems to happen in France. And apparently anyone outside of France has no idea what happens in France. Alright. So, no. Help. Alright. Voted on November 16th, 2018 in Versailles, France, and adopted. When was it? May 20th? May 20th, 2019. All right. May 20th, 20. You always forget where to put those commas. Those commas make a difference, especially if you're doing code. And language, that's basically a code. Or code is a language, I don't know. Okay, file, save. Go back there, go back to our... Wow, we broke the chat assistant. Let's try running that again. Okay, let's go back here. Yes, we can count on counting, Rick. I agree. Oh my god. I thought the mole was a pain in the butt. The candela just irked me so much. I'm sorry. It's... I shouldn't be as aggravated as I am. All right, so let's go back, finish. Let's go into some history of the second because we got that here. I should have done all this personally before. Okay. Alright, second. Time is the most measured quantity on Earth. It tells us what that. Yeah, I mean. Alright. Day and night, 12 parts, 24 equal hours, concept of the minute and the second, date back to H times, origin in the realm of astronomy and not timekeeping. Oh, okay. Sumerians divide the circles 3 to 60 around 1,000 years later. They applied this concept. Alright. Well, Professor Wolfram's big into concept space, so let's alright. Okay, so it was an earthly convenience. But the concept of minutes and seconds was first rooted in astronomy. To help survey cosmos. Da, 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 da. Babylonians and Greeks use this idea to dissect the sky for celestial observations and accounting for where stuff is. Let's just, yeah, we don't need those extra words. Alright. Okay. Yeah, atomic clocks. Atomic clocks. That's a lot of oscillations. Oh, we gotta go to the past. I'll add that to our thingies there. Okay, so we already have that. Alright. Oh, the time thing is relatively short. Oh, God. Sorry, the Mullen Lumen just kind of destroyed me a little bit, or Candela. Yeah. Starting around, phase of moons. Yeah. Okay, so we used the part function wrong. Okay. I am, again, it was a hope and a dream that this would actually work. Okay, so let's do this. Let's literally do what we did with ChatGPT. All right. Here's my code. Yeah, paste. Here's my code, and here is my errors. Here are my errors. we should be able to get all of these dudes. Hold on. Come on. Big money, no whammies. Let's do this. We'll just do this instead. Go this way. There we go. Alright. Put our errors in here. Oh, that looks terrible. I was gonna say, I mean, hopefully you can please help. All right. I think this is just going to require me just setting up literally a basic model and just plugging it in. Again, this was a hope, a dream. All right. Just finish this. Song is on passage day. All right. Dual decimal system. Water clocks. Okay. Let's see. About 5,000. Oh, that's 7 millennia ago. About 5,000 years ago. Egyptians are credited with use of sundials to note the progression of time. Water clocks. Those utilizing bins of tanks, probably better. Tanks of water with steady drip rates were used in Egypt and China to more reliably measure time. Oh, it's liquid mercury to increase reliability as it better avoided freezing than its water counterpart. All right, my music finished, so let's do this over here. We can understand, but the kind. Well, I mean, that's what they were doing, Dan. Can we understand looking at chemistry? Why is the speed of light so fast? Because it can, or at least to observers like us. Rick is saying that he read the second's name because the minute was the first division of the hour, and the second was the second. Oh my god. I can totally believe that. That seems like a very sciencey thing to do. The minute, it's the first division of an hour, and the second was literally the second division. Oh, Dan's saying that seems reasonable. That seems like a very sciencey thing to do. I'm just going back to the Saturday Night Live skit. Okay, hold on. Let's finish this. Alright. Afraid. Okay. Gravity's full. Blah, blah, blah. The candle clock. Standard. Okay. Alright. Candles. Not candela. But kinda candela. Not the hold on. Not the candela per se. Per se. Candela per se. Candles. Been used to track time, but run into the same standardization problem. Candles have been used through history. Time. The hourglass is thought to be a more, I gotta use quotes, modern accounting method arising in the past millennia. There we go. There. Spell that correctly. Okay. First truly mechanical clock. 14th century. Only about 15 minutes today. Alright. Mechanical clocks came into being in Europe during the 14th century and improved over the following centuries. With spring-based technology into the 1700s. All right. Oh, we had the second Santa of the clock. Okay, so okay, so that does seem to be the second derivation. The second, it was, okay, a standard unit of length, the unit of pendulum it took. The marine chronometer, clockmaker, alright. So we were already combining, when was that? around this time when they say, all right, second hand. Okay, we gotta include Huygens. Okay, because now we're literally using a thing of length. All right. A pendulum clock developed. By Christian. Are there two A's in Huygens? Or its first name, Christian Huygens. Okay. Huygens. $16.57. Second, okay. Encouraging the Royal Society of London to propose this as a timekeeping standard. Interestingly enough, this method of timekeeping utilized a unit of length, the distance of the pendulum to swing back and forth. It's almost like I don't know, time and space seem to be very, very important. Okay, so let's save this again. Okay, now I need to run and literally eat lunch in 15 minutes, and then I will be back. Count times 64-bit integers. It's 600 intervals, windows on TIA, but that is very interesting. I think I had a bug in my, walking on my ear. Okay. Okay, so I'm gonna run for right now. Let's save this again because I'm very anal. Okay, cool. All right, so I'll be back in about an hour and we'll continue to crack this out. Actually, I'll either be meeting with my mentor or be back for a short period because I have a pre-lead geometry or something at 3 o'clock. So other than that, I will catch you all in a little bit later today. I gotta wrap up a bunch of stuff, so we're gonna be doing a good number of sessions after. So, all right, we'll see you there.